We are going to start Chapter 3, Section 2, and this section deals with polynomial functions and their graphs. This is going to be spread out over 3 days in class or 3 videos. Let's get the party started. First, we need our definition of what exactly is a polynomial. First, let's check out what the book has to say. Let n be a non-negative integer, and let a sub n minus 1, down to a2, a1, a0, all be real numbers. And the first one, a sub n, cannot equal 0. That's the first coefficient in the line. The function defined by this, we have a sub n, x to the nth power, and then the next term, plus. A to the n minus 1, x to the n minus 1 power, plus. And then we'll go on to a sub 2 x squared, a sub 1 x to the first, plus a sub 0. That's just our constant at the end. And this is a polynomial function of degree n. Whatever the highest exponent is, that's the degree of the polynomial. The number a sub n, the first coefficient, the coefficient of the variable with this highest power, is called the leading coefficient. And to save time writing on the video and in your notes, for leading coefficient, we can do LC. Now, this can be kind of confusing. Here's another way to look at it. What is a polynomial? Well, you're going to have some number and then x to some power. And this is the highest power. That's the degree of the polynomial. And then you're going to have plus or maybe minus. There's going to be another coefficient, x to a different power. Maybe it's one power lower, maybe it's a couple powers lower. And then plus, maybe minus, another coefficient, x to the n minus 2 power. Our powers are going downhill. Somewhere at the end, you're just going to have a constant, some number. And you don't even need that constant. Polynomials don't need to have a constant at the end. The big thing to look for to figure out if you have a polynomial or not is all in the exponents. Where did we have that here? N has to be a non-negative integer. So our exponent has to be a whole number, and it has to be positive. Can't be negative, and it can't be anything besides a whole number. So here we got a couple examples of polynomials. If I look at this one, I see x to the 5th, and then the next power is an x squared. All my exponents are nice, positive, whole numbers, so we're going to have a polynomial. And the degree is 5th degree. My highest power is a 5, so that's the degree of the polynomial. Down here, when we look at this is also a polynomial. If we want to see it a little clearer, we can FOIL it out. If I FOIL out these binomials here, I'll get this trinomial, and then distribute the minus 3x to the 4th, and here's my polynomial. All my exponents are positive whole numbers, biggest ones first, so it is a 6th degree polynomial. Okay, what would a non-polynomial look like? Well, here we have x under a radical, and we can think about that as x to the half power. That is not an integer, so this would not be a polynomial. Here we see 3 over x squared. Remember, we can bring that up and make the exponent negative. Negative 3 x to the negative 2 power. Remember, our exponents have to be integers, non-negative integers. So that right there will disqualify, and this is not a polynomial. Okay, something else about a polynomial, and we can get this right from the graph. If I look at a graph, I can tell if it's the graph of a polynomial or not, because a polynomial function of 2nd degree or higher will have graphs that are smooth and continuous. Smooth just means rounded corners. There are no sharp edges. No sharp edges. Or smooth rounded corners. Rounded corners. Continuous just means there's no gaps in the graph. No gaps or breaks in graph. Breaks in graph. Or to think about it a different way, you can draw the graph without lifting your pencil off the paper. Can draw a graph without lifting pencil off paper. Without lifting up pencil. So down here we got 4 graphs. Let's figure out if they come from polynomials. Well, let's see the first one here. I can start drawing here, and I go up, and then we got a nice smooth turn, and another smooth turn here, and we're going up to infinity. And it's nice smooth edges, and I never lifted my graph or my pencil off the paper, so this is a polynomial. Here's another one. Now this other one went down and up. This one we're up here high, and then we go around this nice smooth edge and this smooth corner and another smooth one, and we're back up. So that is also a polynomial. Nice and smooth. I drew it without lifting my pencil off the paper. Now let's see what happens here. We're coming up this way, and then the graph stops and we have a dot. And then we got to lift our pencil, come down here, and we start the graph again, and now we're going up, up, up. It is smooth, but it's not continuous. We had a break in the graph. So this is not a polynomial function. The last one, if I start here on the left, I come up, and right when I hit this point, I stop and back up. You know, it's a sharp peak. Some books would call that a cusp. Then we're coming down here, and we're still smooth, and oop, there's another sharp edge. So this is continuous, but it's not smooth. So this is also not a polynomial. Alrighty. Now we're going to talk about next called end behavior of a function. You know, we've mostly been focusing on what's going around the origin. You know, does the graph go up and down, look like this? But what happens when we plug in really big x values, when we plug in numbers way over toward infinity, or maybe way over the left toward negative infinity? How does our graph behave at the ends, the end behavior? Well, we have this little test called the leading coefficient test. It all boils down to two things. Is the leading coefficient positive or negative? And what is the degree of the polynomial? And it's not so much what the degree is it even or odd? Even or odd? You know, from those two things, we can figure out quite a bit about how that graph is going to look. You know, what its end behavior is going to be. So two things, the leading coefficient, positive or negative, degree, odd or even. So we're going to break this down into 4 cases. See, we'll start with the degree is going to be odd. And the leading coefficient is going to be positive. A great example to think of this, the most basic, would be x to the third. It would be degree is odd, and our leading coefficient is a positive 1. And what does the graph of x to the third look like? Well, when we plug in positive numbers on the x-axis in the first quadrant, we get positive numbers out. So when we head to the right, we're going to head up toward infinity. And when we plug in negative x values and we cube them, we're going to get negative values on the y-axis. So in the third quadrant, we're going to go down. So that's the basic end behavior of a polynomial function with odd degree and a positive leading coefficient. Depending, you know, this is just x to the third. If we had other terms after it, a minus 2x squared plus x minus 2, you know, the graph is probably going to have some kinks and twists in the middle. We're only worried about what's happening at the end. When we go way out this way toward infinity, where's the graph headed, up or down? When we go way over this way to negative infinity, is the graph going up or down? Okay, let's keep the degree odd, and now let's change our leading coefficient to a negative number. Okay, that's just going to reverse it. Instead of going up to the right, we're going to go up to the left, and then down to the right. Again, we can have some odd stuff happening in the middle, but we're just talking about the end behavior. And remember, odd degrees go in different directions. If you have an odd polynomial, you're going to be going up and down in the opposite directions. And we'll compare that to now even degrees. So here, the degree of this polynomial is going to be even, and our leading coefficient, let's start with positive. Okay, even degrees, positive coefficient, think of 1x squared. What does x squared look like? Well, that's our parabola opening up. We're going to open up to the right and up to the left. Okay, and for the last one, degree, we are still even, but now our leading coefficient is a negative number. Well, if that's the case, we're going to be going down to the right and down to the left. Odd functions, odd degreed functions, go in opposite directions, ups and downs. If your degree is even, you're going in unison. You're either both are going up or you're both going down. And I'd bring up that great question, but that's pretty much what that great question just talked about. There you go. Odd degree polynomials have opposite end behavior, even degree polynomials have the same behavior. You're both going up or both going down. All right, let's try this leading coefficient test out. Use the LCT to determine the end behavior of this graph. Well, my leading coefficient is positive. My degree of the polynomial, can check them all. They might hide a higher degree here. If that's x to the fourth, this would be an even polynomial, even degree. But we are in descending order, and our degree is 3, which is odd. So what does that look like on the graph? Well, if it's odd, we know we're going to be going up and down in the different directions. If it's positive, I like to think of x cubed. In the first quadrant, we're going to be going up, and the third quadrant, we're going to be going down. This plus 3x squared and minus x and minus 3 are going to put some twists and kinks in the graph. But on the ends, we're going to be going up toward infinity as x heads to infinity. And as x heads to negative infinity, our y values are also headed to negative infinity. So again, just those two little bits of information can give you a lot of ideas about what that graph is going to look like. See, now here's one. What we could do to work this out is FOIL this out and then multiply that by the binomial x plus 5 and then distribute this minus 4x cubed, sort of like we looked at here. We didn't do all the work, but that's what they did, is they FOILed this out and distributed that first term. We really don't even have to go that far. If we just want to do this leading coefficient test, well, wrong one, we already did that. Our leading coefficient, the only coefficient I see here is that negative 4. If there were others, we could multiply them through, but we don't have to. Our leading coefficient is negative. Now, what's the degree of this polynomial? Well, let's see. The degree of this term is cubed, and the degree of this term is squared. And you don't see it there, but there's an implied 1, so that's a first degree. And we're multiplying all these together. What do we do when we multiply like bases? We add exponents. So our exponent is 6th degree, and it's even. All right, so what's the end behavior of the graph going to be? Well, we know it's even, so it's going to be going up or down together. And it is a negative leading coefficient, so that means we're going to be opening down to the left and down to the right. Again, these other terms are going to put some twists and kinks in the middle. We don't know what that looks like, but we do know the end behavior. Okay, and this is sort of a common sense type thing. Let's say you're taking the SAT test or some other standardized test, and you punch this polynomial into your graphing calculator, and you hit the graph button, and your window was set on the x-axis from -8 to 8, and your y-axis from -10 to 10, and the calculator shows you this graph. Is this a complete graph that shows the end behavior of the function? Well, let's think about it. Our degree is even. It's a 4th degree. And the leading coefficient is a negative number. Well, if it's even, it's going to be going up or down on each end together. And if it's a negative leading coefficient, we know we should be going down to the left and down to the right. So is this graph representative of what's really going on? No, it looks like we're zoomed in too close. Oops. See, it looks like this part is good. That's down in the 3rd quadrant. But this part here, our graph is incomplete. Maybe the function goes up, and then outside of the viewing window comes back down. So we don't really have an idea what the end behavior is. And here is that the same graph with a much bigger viewing window. Notice here the x-axis was 8 to -8. Now it's 10 to -10. But look at the y-axis, or this must be the x. They must have it sort of backwards there. Here it's much bigger on the x-axis, from -1,000 to 750. So make sure you use a little common sense. Don't rely too much on those calculators. They're nice tools, but be careful. They're only as good as the person using them. Some practice problems for you to try. Shouldn't take you too long. Pause the video, try them out, and see if you got them right. All right, the first one, use the leading coefficient test to determine the end behavior of the graph of this function. Oh, leading coefficient, positive. Degree, even. Even degree, positive, means we're going to be going up. We're going to be going up to the right and up to the left. All right, number 2. Use the leading coefficient test to determine the end behavior of this graph. Again, we could FOIL that out and distribute this other term, but we don't have to do that. Our leading coefficient, positive 2, positive. Degree. Again, we have it in chunks, but this term is a third degree. And then here we have implied ones. So we have another first degree and another first degree. We're multiplying them all together, so we add up the exponents. We get 5, which is odd. Positive and odd is like x cubed. So up in the first quadrant, down in the third. The last one, here's our polynomial. Underline it here in black. And we try to graph it. Here's your window on your calculator. Is that the representative of the end behavior of the function? Let's see here. We have a positive coefficient and an odd exponent. Positive and odd. Well, that means we're going to be going up to the right and down to the left. So this part looks like it might be good, up to the right. But the down to the left, we would have to, again, probably zoom our window out to catch this part of the graph where we do take that bend down toward negative infinity. For homework, some of these, I think they're just saying find the degree of the polynomial. Is it odd or even? 15 to 18 are matching. So there are 4 polynomials and 4 graphs below. Match the polynomial to the graph. Just concentrate on the end behavior. 19 to 23 also. None of these you have to graph anything for. Just you're working with a graph that's already been provided, or just doing a little quick end behavior. Something like this if you're going up to the right and down to the left. All right, have fun.